When we talk about artificial intelligence, it's pretty easy to just picture one single massive goal, right? But here's the thing. The quest to build an intelligent machine was never about taking just one path. It's actually been a journey down four very different and sometimes competing roads. So let's explore the very foundations of AI.
It really all boils down to this one question. Seems simple on the surface, doesn't it? What does it actually mean for a machine to be intelligent? For decades, this very question has been the engine driving this entire field, and, well, the answer is anything but simple.
That's because there isn't just one answer. There's no single definition of intelligence that everyone just agrees on. Instead, what the history of AI has really given us are four different answers, four completely different targets that researchers have been aiming for.
And this grid right here, this is basically our map for this whole thing. It lays out these four approaches perfectly. Look, on one axis, you've got the focus. Are we talking about the internal thoughts of the machine or its external behavior? Then on the other axis, you've got the benchmark for success. Are we trying to make it like a human or like a perfectly rational ideal? And boom, that gives us our four quadrants: thinking humanly, acting humanly, thinking rationally, and acting rationally.
Okay, so let's start our journey on the top half of that map, the human-centered paths. For these two approaches, success is measured against a pretty straightforward, if incredibly difficult, standard. How well can a machine imitate us?
First up, and probably the one you've already heard of, is acting humanly. This is the home of the famous Turing Test. The one Alan Turing dreamed up way back in 1950? He brilliantly decided to just sidestep the whole deep philosophical debate about whether a machine can think, and instead asked a much more practical question. Can a machine act so much like a person that you can't even tell the difference? So how does this whole thing work? Well, the setup is actually pretty clever. You have an interrogator who's typing questions to two participants they can't see. One is a real person, and the other is a machine. If, after a good long chat, the interrogator can't reliably figure out which one's the computer, then the machine passes the test. It's all about the behavior. And this is where you realize just how massive of a challenge this really is. To convincingly pull off a human imitation, a machine needs the whole shebang. It needs natural language processing to just understand and talk like us. It needs knowledge representation to store everything it knows. It needs automated reasoning to use that info and machine learning so it can adapt and see patterns. This is so much more than just a clever chatbot.
Okay, so let's switch gears to the other human-centered approach, thinking humanly. Now, the focus completely flips from the outside to the inside. The goal isn't just to talk like a human. It's to actually build a computer that thinks like one by modeling the messy, complicated internal processes of our own minds.
So how on earth do you even begin to do that? Well, researchers try a few things. First, there's introspection, which is literally trying to catch and map out their own thoughts as they happen. Then there are psychological experiments to see how people actually solve problems. And, of course, nowadays, we have brain imaging, which lets us see the brain in action. You take all that data and try to build a program that works the same way. So let's just nail this down, because it's a really important distinction. Both of these paths use us, humans, as the yardstick, but they're measuring totally different things. Acting humanly is all about the final performance, the behavior. Thinking humanly is all about the process, the gears turning inside. One asks, does it act like a person? The other asks, does it think like a person? All right, let's cross over to the other side of our map, to the rationality-centered paths. And this is where the goal just completely changes. We're not trying to be human anymore with all our weird quirks and mistakes. The quest now is to be perfectly, ideally intelligent. This brings us to thinking rationally, which is often called the laws of thought approach. The whole idea here is to build systems on a rock-solid foundation of formal logic. The belief is that there are these perfect, unbreakable rules for reasoning, and if you can just get a machine to follow those rules flawlessly, you'll have created a system that is always, by definition, thinking correctly. And get this idea is ancient. I'm talking all the way back to Aristotle and his syllogisms. Those logical arguments that always give you the right answer if you start with the right facts? That dream carried right on into the computer age. By the mid-60s, we actually had programs that could, in principle, solve any problem you could write down in logical code. But, and this is a huge but, there's a massive gap between in principle and in practice. Pure logic runs smack into two giant walls in the real world. First, real life is messy and uncertain.
How do you possibly write something like, I kind of think it might rain later, in perfect formal logic? You can't. And second, even problems that sound simple can blow up into a computational nightmare that no computer could ever solve.
And it's exactly those problems that pushed researchers to our fourth and final foundation, acting rationally. This is the rational agent approach. Now, an agent is just something that does stuff. A rational agent, then, is one that acts to get the best possible result. And here's the key. When it's not sure, it acts to get the best expected result. The focus shifts to just doing the right thing, not necessarily proving it with perfect logic first.
And you can probably see why this approach really took off. It's just so much more flexible than pure logic. An agent can make a good, rational choice even without being 100% certain about everything. Plus, unlike trying to be human, rationality gives you a clear scientific benchmark. You can actually measure how well an agent is doing and make it better.
So let's just draw that line super clearly. Thinking rationally is obsessed with perfect logic. It's all about, is the reasoning provably correct? Acting rationally, though, is way more pragmatic. It's focused on getting the best outcome. It just asks, did the agent do the best thing it could do, given what it knew?
So after this journey through all four foundations, you got to ask, right? Where did the map lead us? Which one of these philosophies actually defines AI today?
Well, the answer couldn't be clearer. The acting rationally approach, the whole rational agent idea, has become, and I'm quoting the source material here, the standard model prevailing in modern AI. This is the one that won. It's the framework behind almost all the AI you see and hear about today.
So, in a nutshell, this is what modern AI is all about. Building these agents, whether it's a self-driving car, a movie recommendation system, whatever, that can perceive the world around them and then take actions to maximize their chance of success at some goal. It's practical, it's measurable, and it turns out to be incredibly powerful.
Which leaves us with one last, really fascinating question to chew on. For so long, we compared AI to our own, very human, very imperfect intelligence. But now, the main goal is this perfect rationality. So the question is, as these systems get better and better at acting rationally, is that line between what's optimally rational and what we think of as truly human going to start to get a little blurry? It's definitely something to think about.